Excellent. Okay.
So Gory, I was just checking. I'm going to share the charts, but I thought you were going to talk through them.
That is my plan.
Okay, great.
Okay, I'm going to wait 5 minutes to reply to all the people who happily told me that somehow the MeTecho time was wrong. And then I'm going to transfer to a different computer, and then I think we're ready to go. We'll also need a note taker, so any offers to take notes would be gratefully received.
The note-taking tool doesn't seem to work. It says that I am not allowed to access this page. Maybe try logging in.
Jonathan, did you try logging in?
Well, I am logged into the data tracker.
Yeah, right. Okay, that's the extent of my help. I will work on trying to get people into the meeting room.
Well, Jonathan, if you'd like to, we could take notes the old-fashioned way, where we take the minutes offline and then send them to the chairs after the meeting, and we will update them and post them. That was how we used to do it in the bad old days. We could go back to that.
I just changed the permissions so everybody can edit the notes.
Oh, perfect.
Oh, what feeling of power. Well, thank you ever so much.
So I'm not seeing anything in the notes yet.
Well, I'm still loading the page.
But I'm
Okay.
seeing people coming online. So there are 5 people online now. Test. So it seems to work.
Okay, let's see if I can take notes for a change.
Thank you. That'd be terrific. People who have been joining, we're in a holding pattern for a couple of minutes while we wait for everyone to find the updated meeting link and join in. Is anybody there?
There are people here.
Gory, the pace of people joining seems to have died off, so it's probably okay to start when you're ready.
And I just updated the copy of the link that ended up in the notes.
I guess while we're waiting for Gory sub too, I'll note David is joining us late today, so we won't expect him, I think, during the first hour.
I don't hear Gory.
We can't hear you.
I don't even hear him pounding on the table.
We still have nothing from Gory. I think you might need to start looking for mute buttons.
He's not muted in Meet Echo.
No, but there's probably mute buttons elsewhere in the audio chain.
Well, you have to select the correct input.
This is also true.
What?
Yes.
Yes.
Okay. It's probably not the best, Mike, because it might have more echo than any other mic I have. Right.
That is a lot of echo.
Yeah, right. Yeah, I know.
I think Joe is echoing.
Really?
Try again, Gory, in case it was coming.
I'm going to try muting everyone else, and you can unmute again if you feel happy. Does that sound okay?
That is much better. That is much better.
Good. This is not my favorite choice of mic, but I'm so pleased that we have managed to create a meeting and start it. So at this point, I think I would like to go through the chair slides and talk about what we're going to do this meeting. This meeting is covered by the Ietf Note Well. Most of you should have already noted this. If you haven't seen this slide before, please do take a time to look at it. It calls out that you must declare Ietf IPR. Any IPR you have, you must mention, or you must stay quiet. The legal explanation is in the words. Note it well. Next slide, please. The organization of the meeting. This meeting uses Meet Echo. Wow, that was a bold statement. It does, and it appears to now work perfectly. We need a note taker. I believe that Jonathan volunteered. Is that correct, Wes?
Yeah, Jonathan's doing it.
Excellent. We have 2 hours or just short of that. Speakers should keep to time, but there will be time for questions because this is an interim. We have more time allocated to questions and comments, and we will, as usual, follow up on the list with any decisions made here and also with any questions which we don't have time to answer. There could be many topics we bring to this interim, but there will be a focus on just 2, which is the SCTP drafts, which we haven't yet talked about much at the last Ietf meeting, and the UDP options draft, which we will be looking forward to finding more about at this meeting. So next slide, please. The agenda is the last copy that was circulated, and we are currently in the agenda and organization part of our agenda. There'll be a short chairs update as part of this slide deck. And then Joe Touch will be leading a discussion on UDP options. Hopefully Joe managed to connect. I didn't check he's here. Joe, are you here?
Can you hear me?
I can. You're a little quiet, but
I can amp that up a bit.
okay, that's perfect. Okay. After Joe,
There's a lot of echo through Joe's connection, so he should mute when he's not speaking.
yeah, we'll work out how to manage the echo better. Thanks, Jonathan. We'll also talk about the Datagram PLP MTUD draft, which is designed to work with UDP options. And I'd love the working group to consider in this meeting whether we can adopt this as a work item. So this question will be coming up at this meeting, exploring whether the 2 documents could proceed together as they head towards a working group last call. So that discussion to come. Next slide, please. The second hour is devoted to SCTP. We have 4 SCTP topics to talk about. The RFC 4960 update, the NAT activity, which comes in 3 parts, a discussion by Michael Tuxen on containers, NAT alternatives for SCTP with information provided during the working group last call, but now with a separate draft talking about this, and we'll explore hopefully where the differences are between this and the current work item and how best to progress. Finally, Michael will talk about that work item when he talks about the TSVWG NAT support document. We do have an item for any other business, and if there are any other items that people think we should bash the agenda with on these 2 topics, could you please come to the floor and use our Meet Echo. Tom?
Slides are in the tracker, but there's not on the agenda. So I also have a couple of minutes on UDP options implementation status. I just don't want to surprise anyone.
Okay, that would be good. And if anyone else has inputs on implementation status or how they would like to use UDP options, then make sure you bring that to that part of the meeting. Any other items to bash the agenda? Okay, consider the agenda bashed. There's a chair's update slide here. One announcement is the multipath DCCP draft was adopted, and that now is a work item. We will likely have an interim or discussion on the mailing list, whatever is needed to progress that in the normal way. We are talking about ending the working group last call for SCTP BIS. That will be in this particular meeting. And I guess Wes should say 1 or 2 words about what happened for the L4S draft, just as a chair's update of what will be heading to your mailbox right in a few days' time. Are you able to do that, Wes, on the fly?
Yeah, can you hear me? I'm hoping it's less than a few days' time, but we've been working together among the co-chairs to assess and summarize the results of the working group last call on the suite of L4S documents, and should be sharing that soon. There are some concerns that people have raised that will need to result in a bit more work to make sure that the working group has considered them thoroughly and the right things happen according to whatever the consensus is. And I hope to be sending that summary actually later today if I can get the co-chairs to agree that I've phrased everything correctly. I think you're muted.
Goy is still muted.
Yeah, I'm trying to get the muting right. I don't have anything else on a chair's update, so I guess we could take the next slide if there is one. That's a perfect slide. That indicates that we've now ended our chair's session, and we can move on to the first topic, which is UDP options. So maybe Joe could
I'll take the
join
helm.
the queue. And would you prefer Wes to take your slides, or would you like to try presenting them via me, Teco? Oh, already appearing. That's good.
Yeah.
Go ahead.
So this is just a review of the stuff that was presented at Ietf 111. Next slide. So there's a whole bunch of updates that happened since 09. We added the maximum reassembled segment size in addition to the maximum segment size to be an explicit indicator of how big the receiver can reassemble things. This was brought up during 110. We split authentication and encryption into two different ones, one for authentication, one for encryption, because authentication is safe, doesn't change the user data, but encryption is not. And so we added that to this unsafe set that we created around Ietf 110. And we redesigned the frag option to support more efficient fragmentation, reassembly, and offload. We also clarified that MSS is a hint, not a guarantee, the same as TCP. We updated the robust OHC. I can't remember what it stands for, but it regardless, we just got rid of it because there was a misunderstanding in how it worked. It was compression, robust overhead compression. The control block sharing was mentioned the same way TCP works. We also talked about the difference between the length versus the extended length. Mentioned the fact that post end of list, all of the bytes after it are 0 on transmit and not checked on receive. And we hope that's useful for things like padding for the PLP-MTUD option, and Gory can answer that later. We allowed up to 7 no-ops in a row from 3 so that you can do 8-byte alignment instead of only 4-byte alignment. Next slide. None of this is new. This is all the same slides. Again, we split authentication and encryption into 2 separate options. Next one. New frag format right after OCS. So it allows you to not have to process the whole TLV chain to do offload processing. It has a field that points to the front of the frag data. For non-terminal fragments, this allows you to have options after things. So for example, the packet would look like, and we're going to put a new diagram in for this, the packet would look like OCS, the frag option, and then as many options as apply per fragment, and then the data of the fragment. But for the terminal one, the idea is that it's OCS, the fragment, the options that apply per fragment as in opt1 and opt2, and then the data, and then after you reassemble everything, you can treat the data and the things following the data, the options following the data, as part of the reassembly, so that when you're done, you end up what would have been a packet that you would have sent had you not had to do UDP fragmentation. So you have data and then the options following it. It's designed to have basically the same per segment option processing as the legacy format. And that also ensures that there's no limit on segment option length. So it actually allows zero length fragments so that you can have, if you're done finished reassembling your user data, but you still have options, that those trailing options are more than one fragment, you just declare that your user data in those messages is zero length upon reassembly, but you just have the data after it, and it just works right after that. Next slide, and there'll be slides to explain, better pictures to explain that in the update. Next slide. So this is the pending issues. We need to talk about the support of fragmentation. If so, is it required or not? And if so, how big is MRSS? Is it limited in terms of packet number or bytes? We have to figure out this offload support and to what extent we are customizing for existing hardware versus making a system that is essentially equivalent in form before, whether you do reassembly or not, and then what the future of the things is. I'm a little worried that I don't want to over optimize for the hardware that's out there today, for the same reason that wouldn't have made sense for TCP because there wasn't any, right? Let's see, the option encoding is frag versus non-frag option set by the user or a fixed option. Is it encoded in type? So this is the issue of, we have different types of options, okay? Some of them clearly make sense per fragment. Some of them clearly only make sense per segment. And some of them it's ambiguous as to how you want to do that. In particular, the encryption one. So the question is, are we going to allow options to be used in either format, or do we basically encode that in the bit of the option, in the way the options are represented? The concern with assigning a bit for that is it burns a whole bunch of space for a lot of options that we don't know that we're going to ever use. And that goes to the question of, how do we encode unsafe? Is it a code point plus a subtype the way it's listed now, or is it a separate code point region? And if so, how big? And then we've got a lot of clarifications, inconsistencies. Let's not dwell on those today because, yes, the document needs many different passes to catch everything. I appreciate the feedback that everybody's given, and all those things will be put in. I know the document is inconsistent right now, but I hope the intent of where we're going is pretty clear. So in the past 24 or so hours, there has been a flurry of activity of emails, and I'm not completely sure I'm going to catch everything in them. I believe we may have converged upon the use of the OCS field as required and 4-byte aligned. Does anybody have an objection to that?
I'll try joining the queue. Can people hear me now?
Yeah.
Excellent. So I think that's what was just said on the list. So that would be good if we have actually converged. I like the option. I like the idea of aligning on the 4-byte boundary. That seems to make it useful if you do know where the 4-byte boundary is. And I like the idea of the OCS being
Boundary
expected
after
to be present. I guess if it's not present, when you pass the packet, you find it's not present, but that's not inconsistent with saying that it's always in the same place if it's present. Is that what you're getting to, Joe?
No, yeah. So the question is, if it is always first, we might as well just put it there and have it be 0 if it's not used the same way the UDP checksum is. And that's fine.
Yeah. At the moment, I guess that's what the mailing list is saying. So,
yeah, that's what I got from the mailing list too, right? I think that when it comes to the unsafe encoding, and I'll jump down to that one, which is sort of like the third bullet here. I think we converged on a block, but not a bit. So in other words, it would be, it's not that a single bit allows an option to be used in either place. It's that an option, when it's defined, is intended to be used in one place or the other, and that's it. And that you know from the bit type whether you are using those or not. And if you ever hit one of the point of the unsafe is if you hit one of those, regardless of where it is, then you basically throw it's basically it's a mandatory to support option that if you don't support it, you must drop all options and ignore all of them, right? The same way you would if you got a bad OCS or something like that, except you don't report the same kind of error, you report a different kind of error. I can be more clear about that, what that means in the thing. I think people who know about the unsafe option know what that is, but I think what we're converging on is something like a 32 option block or a 64 option block, but not 128, and specifically not using a single bit to indicate whether you copy on frag or not, because that only really ever made sense in IP because you were sending it to intermediate nodes that didn't know whether to copy it or not. Whereas in our case, that never happens. The endpoints always know what's going on. So it should really just be the if it's an option that you don't support and it's in the safe area, you can silently ignore it. Whereas if it's an option that you don't support and it's in the unsafe area, you terminate option processing. I think that's what I got from the list, and I think that the group size is probably going to be 32. Any objections to that?
I don't hear anyone saying anything or anything in the chat regarding that part. Mike Hurd says something.
Yeah, I see it. I'm repeating it. It says that it might unsafe means you need to drop the packet. You don't drop the packet, and here's why. If you ever get options that you don't understand in a regular packet, if your OCS is wrong, you don't drop the packet. You have to deliver a 0 byte. You have to deliver the user data, whatever it is, because that's what a legacy receiver would have done. So you can't turn around and say, I'm not going to do what a legacy receiver would have done. Now, the receiving app can decide that if that happens and if there's a flag, that it ignores the packet, or maybe it sets the socket in such a way that if that ever happens, it never gets the signal. But the default has to be that you have to deliver the user data if it is received, even with a corrupted OCS. So this has to behave the same way, no?
You want to talk? Want to press the mic button and talk to us?
Audio. I'm giving you a chance. I'm muting myself. Okay. Unsafe is a weird term for critical options. Well, if you have a better one, let me know, but that's what it is. It's unsafe. It means that your user data has been modified. And so what you're saying is that you don't want to pass the user data back up that's modified by this. But you're really only supposed to use it in a way that is encoded with the frag, so that it only applies before the reassembly, or it doesn't, you can't let it get, basically you have to let it be that you get a 0 length packet back to the user, because 0 length, the UDP packets are valid, and Corey pointed out, I think, a ref in 8085 to point that out. So that's why we're saying it is unsafe. It's the difference between safe one is one that you can use for legacy ones, or maybe it's legacy compliant or something, or if there's a better term, let me know. But that's what we've been using up till now, and it's been that way for a while now. Cabo, and I'm sorry, I apologize, I don't know who that is, mentioned that we don't need alignment. We know that we don't need alignment. We're selectively picking to lead alignment. I think that's what the consensus on the mailing group was. Let's see.
Carsten, do you want to talk to that?
Yes. So just on the terms, of course, any pair of terms will do. And when we design CoAP, we call them critical and elective options. But I really raised my hand because I'm trying to understand this concept of a legacy receiver. So a legacy receiver is one that doesn't understand UDP options. I would expect legacy receivers to be very confused when the UDP length doesn't fit the datagram length. So I have no idea what they will do. Have you done a survey of that?
Yeah, we found out that basically it delivers the UDP length. It doesn't deliver the IP length.
Who's it?
And so what we're trying to do is to say that if you send something this way, it should behave the way it would behave for a legacy receiver, which is to deliver the UDP packet.
Okay, so once you use an unsafe option, you cannot have data. You must put everything into the options.
That if you use an unsafe option and you don't, so I as a transmitter use the unsafe option. The issue isn't whether I use it. The issue is whether you get it. So if you're the receiver, right? If you're a legacy receiver, you would have received a zero-length data packet. That's what it would have ended up being because of the way we're doing options altogether anyway, right? Okay, so unsafe, safe doesn't matter. You would see a zero-length packet in the unsafe case. In the safe case, you would see real user data, the user data that was in there, right? This is the unsafe case. We basically never send traditional UDP user data. We encode all that data in essentially a zero-length frag or more than one frag, so that we hide it from the user. We stuff it in the option area, so that we hide it from the user. Okay.
Thanks.
So if you get one of those and don't understand or don't want to say I don't support that option, then you should do what a legacy receiver does, which is deliver a zero-length packet. It's not the same thing. It's a subtle difference between deliver an unsafe packet and drop the packet. There's almost no cases where we drop the packet. You have to have a UDP checksum fail for UDP to drop the packet, but we never drop a packet because it just doesn't make sense to drop a packet. The only place where you could say we do drop a packet is where we're in the middle of reassembly and we never get to the point where we finish putting a packet together. Then we drop what we're reassembling, yes. But we never, once we have a reassembled packet or a packet that hadn't been fragmented, we never, ever completely drop it. There's no reason, because no matter what's in this extended area, there's no reason to do that. Now, I think there was one case somebody came up with and said, well, we're using the pointer where the IP address, the IP packet length points further out than the UDP packet length does. What if you turn that around and made it shorter? That's already used in Teredo, so I can't turn around. I mean, I think we are trying to deprecate that, but I don't know that we should or could. It's a completely separate use, and it does something that I don't understand how or why it works, but that's what it does.
Okay, thank you.
Mm-hmm.
So the mic line's still open if you have a question.
I'll go because I left by accident. Joe, I think on the unsafe and frag, I think the rationale you just gave was very good, but this is missing from the draft, and I think this would really help clarify how these options are meant to be used together and the expected behavior. I think from reading the draft in the last day, the entire treatment of errors needs to be rethought and really clearly spelled out in the draft. I think right now it's very difficult to tell what to do.
What was that word before, to rethink and re-explain what?
The treatment of error.
Oh yeah, okay. Yes. So yeah, I
Text
completely
comments?
understand. Go ahead.
And could you put those comments into an email, perhaps?
Sorry.
Suggestions on how to make the document better, please do. So here's the thing. What I did when I remangled, if you will, the document to adjust the fact that Frag was now, we merged Frag and Light together. That was sort of the big change to the document. When I did that, I decided that it would probably be better to get a draft of what I was thinking into the document and start to get feedback rather than polish, make it clear everything else at the time. Now that we've converged on that, I fully appreciate the fact that the document needs a top to bottom scrub, much more clear update, and that will happen. It may not happen as 14, it may happen as 15. I may just do some short changes in 14 so that we can track them. And then I may do a more major rewrite for clarity in 15 as a separate thing. But I completely appreciate that that is a necessary pass that has to happen with the document right now. More examples, reorganized, consistency, all that kind of stuff. I know it got that way. I kind of let it get that way on purpose because, like I said, rather than invest a lot of time trying to do that before we had converged, I wanted to wait to get at least a little feedback on it. But I think we're there on that. And especially after this meeting, I'm hoping that we can get to that last issue now, which is also, I think, the two issues that remain, and we can also open up the floor if there's ones I forgot, because I don't know if those ones I forgot, especially once it got brought up in the past 2 days. But we've been talking about this MRSS issue. Basically, is it required? Is fragmentation required? And how many frags? And how big? I think we have converged upon two frags, or basically at least a total of, well, it's at least 2 fragments, but we also want to make it be at least 1,500 bytes, or maybe a little bit more than that. So because we're saying at least 2 fragments, my intuition is to say, why don't we say that you must be able to reassemble up to something like 2,600 or some number, which is basically 2 times the IP size, or 3,000 if it's the 2 times the IPv6 receiver MTU. Pick some number like that. And if you can, basically the idea is, if you can do it with, I'm a little hesitant to say that the we want to limit the frags to 2, because if somebody says, well, my MTU is only 500 bytes, then that could be 6. Are we only going to limit the size up to 1,000 because of that? I'm worried about the V4 V6 issue there. So 2,600 and 3K were suggestions to Gory. I'm happy with either one of those two. I think something like that makes sense to me, at least. I think Tom's okay with it. Cabo's saying 1,500 or 1,280. The problem with that is we're sort of like putting ourselves right back into the IP place. And the whole point of the frag in UDP was to get around the IP limit, especially. So I'm hoping we can at least get around the IP limit. There's good arguments for a lot of different numbers here. There's good arguments for even like 4096 is potentially a good argument because it's a block size of certain things. But I think 2,600 or 3K is pretty good. The question is, rather than say that it has to be 2 fragments, should we just turn around and say that the minimum fragment, give a minimum fragment size or something like that, or a maximum number of fragments or whatever it is? Because I'm a little bit concerned that if you say 3K, right, then somebody can come back with, 3,001 byte fragments, and we don't want that, obviously. So how do people think about that?
Mike's at the top of the queue. Go ahead, Mike. Maybe I could have a go, Joe.
Okay, so I'm reading Cabo's statement. He says no, 1500 was not just don't use that as the calculation. Use 1280. The MSS size doesn't really matter. Okay, yeah, agree.
Right. Okay, so I put a straw man in the poll, Joe.
Okay.
About whether we could actually require something simple in the receivers that you expect to be present. I know you can choose to have many fragments, you can choose to do various things, but is there something basic that you expect a receiver to be able to reassemble that you could use if you know or believe it supports UDP options? You could say reassemble this many packets. That's where the number comes from. Not to say a maximum number you would ever see, but just to say this is the minimum that you would expect a compliant system to build.
Right. Yep. Yeah, and the minimum comes into play so that you can do this without burning around trip time. I think Mike's on the queue.
Gory asked me to put some stuff say some stuff out loud that I put in the chat. I am certainly okay with what you said about OCS and unsafe. The one thing that to those who aren't familiar with this, it's important to note that unsafe only hides behind a frag option so that it's never in bare legacy UDP data.
But if you send something with the unsafe option, a legacy receiver would get a 0-byte packet. And that's the behavior we want, I think, if you get an unsafe option you don't support.
So, Joe, I don't see other people in the queue. Are there any last? Oh, Mike again.
Oh,
Mike.
Okay. So I'm gonna suggest.
All right. I just. Oops, we've got an echo.
Yep. Hang on.
Thank you. I just wanted to say that I believe we've got kind of an overarching dispute that's ongoing and unresolved about the degree to which the application or upper layer protocol on top of UDP gets to control the details of what go into fragments and options that are carried in them. I don't want to belabor that at this point, but to carry it back to the list and just indicate that I personally at least was not satisfied that we had a proper resolution. And I have some other minor things that will show up later on the list. And thank you, Joe, for all the hard work you did on this.
Yeah, so let me see if I can come to the closure on MRSS. I believe that we are, correct me if I'm wrong here, converging on the fact that fragmentation is required, support is required, that you have to be able to support at least 2 by 1280. I'll pick that number, I guess, is just as good as any. And that therefore you have to support at least 2 fragments to do that. So those are the minimums, right? And obviously, if you support more than that, that's fine. And if you do support more than that until the other end, they can use it, that's fine. So that's all good. But I think that's where we are. The issue of how much apps decide what goes into frags, I really would appreciate a better description of that issue on the list so that we can get to it. My view is that because this is the U in UDP means that I believe that a lot of this should be under app or user, I'll say override control without needing root. So in other words, there's lots of things you can do with almost any protocol, right? But I think that a user who doesn't have root should be able to do almost anything they want to manage their socket with regard to how it uses UDP, because it's a user protocol. So I think it should be their choice as to what they do. But that's really what my logic is behind that. I think the one big issue that remains is where, well, it's sort of a combined issue. It's where the frag option itself goes and whether it is it's the same question. It's whether it's the separator between pre and post options, pre and post reassembly options, or whether the post reassembly options come at the end of the fragment, the end of the packet. I think my view is that one, that the frag option should come immediately after OCS to make it easier to allow hardware to find it, right? Because now that we've got OCS in a fixed place, now if you've already known that whether there's a frag or not, you'll know it immediately right there in a fixed location. Well, fixed because it's based on the UDP length offset, right? And so putting it there makes a lot of sense. And then to me, again, putting the post reassembly options at the end in the last frag or the last set of frags allows it to be unlimited in length, and after you do reassembly allows the packet to look identical to how it looked if you didn't do reassembly in terms of the further option processing. So how do people feel about those two?
I think you stated. One question I'd ask of you is: would you expect the upper layer or application to be able to say send this individual fragment with these options, or is that something that you don't see as being under application control? I would not. I would not.
No, it's more like I was thinking more like the application should be able to, I mean, there should be at least a informational suggestion about what the API to this might look like. But I think it would basically say that there should be OS defaults. The following things should be considered, and most of them you should be able to override on a per socket basis. But I don't think a per packet basis is where you override any of them. So, for example, you'd be able to say, I would like my fragments to go out this big, or I would like to let the operating system figure it out, or I would like to make this option per fragment. I mean, it's in the option now, right? Well, no, it's not in the option. I would like to make this option per fragment, or I would make this option per at the end, or whatever it is, right? But to do that on a per socket basis, if you want to do it on a per packet basis, you're gonna have to do socket change packet send, socket change packet send, and that becomes crazy. So I don't think it should be. I think it should be something that you recommend gets set once.
Well, Joe, that sounds like you've got some useful input, and I think you're taking the right things forward on the list. So please continue this on the list. And when are you next expecting to prepare a rev of the ID?
What I think we're converged on, which I think includes also putting the OCS, the frag right after OCS, and allowing the post reassembly frag. I can probably get that done in the next week or two.
Excellent, because it'd be good to cache and keep the stuff that we've agreed on, and we can move forward afterwards on the more difficult issues that we need to discuss.
Right. So what I'm going to propose is an update with these changes, and I'll try to get as many semantic changes as I can that have been suggested, but I'll try to hold off on the clarification changes in 14 within 2 weeks. But I want to lock that in as a change, and then I'll go back and do another pass after it, which won't, I'm not hold up on anything, but that's just so that people can see it, right? And I'll do a pass after that for clarification with all the other changes. So if you have a change or a bug or an error, please don't think I missed it if it doesn't show up in 14.
I think we'll move on to the DPLP MTU draft. If Tom could take the floor.
No. How do I do this?
You could just raise your hand, and Wes will make the slides appear.
Okay, that's the easiest way. Next slide, please. Hi, so I'm Tom Jones. I'm one of the people with the strange distinction of being able to say DPLP MTUD. We published last year RFC 8899, which generalized this method. So hopefully the presentation of this shouldn't be really new to anyone in the working group, because we've been talking about this a lot. Gori and I have a draft, and it offers a mapping between the DPLP MQD algorithm that we have in RFC 8899, the options which were originally in our draft and are now in the UDP options draft, which enable the use of non-data probes. So it allows us to make probes that don't use application data to try and figure out the path MTU of the network. This document is mostly the fault of our working group chair, our AD, who very helpfully suggested we make a mapping draft that could be an influence for other protocols to support DPLP MQD. And so we have this. It's nice and short. It's 7 pages plus appendices, so you should read it. Next slide, please. We use these two options that we added and Joe has incorporated. They're the echo request and the echo response option. We think that they might just be generally more useful, and so they're not a path MTU discovery option. They allow you to send a 4-byte nonce, which can be then echoed back. And so this is transparent to the peer you're speaking to. They don't actually know what the nonce contains. And it's used to track probes, so you can see which probes have been responded to. Next slide, please. And this allows us to implement DPLP MQD, and it allows us to build a simple state machine inside the kernel, or for speaking with Joe this week, maybe in an application that gives us this functionality. And inside the kernel allows us to provide a service to a UDP application that allows us to have confirmation of connectivity, because we now get ability to ping across a path, the ability to send probe packets, so we can send packets that are inflated to a larger size so we can verify what the path will carry. We can validate the path with UDP options, which allows us to confirm that packets make it through. So confirmation and validation are different. Confirmation says we have connectivity to appear at the other end, and validation says that the path works with the packet size we're trying to send. And then we can integrate in both black hole detection for paths that don't have packet too big message support, and we have the ability to integrate these into. And so this gives us an ability to implement RFC 8899, which we like. Next slide, please. We've been pushing on this very slightly for the last year, and so we've done 2 revs, but we're not seeing massive steps forwards in this. So we've reworded text slightly. We've removed a paragraph on packet 2 big suspension. The last draft of year 5, we just fixed typos. we now have suggestions from Mike Hurd on some clarifications. One of these is to remove responding to multiple probes by using multiple response options, and so we will publish that in a 06 probably quite soon. Next slide, please. And we have implementations for this. So we at the University of Aberdeen have 2 implementations of UDP options. We have one which is SCAPI, which is a testing framework, and we have another one which is in the FreeBSD kernel. One tests the other. And as part of this, we have implemented this, and we can say that it works. But it's us saying this again. But we have implementations, which we think is always a great step for IETF work. Next slide, please. And from here, this is where we want to ask TSVWG if the working group will adopt the current spec we have. We'd like to pair this with UDP options. I would love to get more feedback from the working group. I think with Mike reading the document this week, it's clear that we still need to do more work, but we think that work can happen as a working group document. And so we'd love to hear what the working group thinks.
This is where we do an adoption call, I think. I already see some feedback in the chat, but we should probably try to use the tooling here to do an actual call for a show of hands. So we'll confirm on the list whatever may happen, but I'm going to try to ask people to look at the show of hands tool and ask if we should adopt this to publish concurrently with the UDP options draft. So I believe you should see a notification that a virtual hands session has opened, and you should be able to click raise hand or do not raise hand. And I'll leave the session up for about a half a minute here and let people find that and click. Mike, I see you asking in the chat, where is that tool? Do you see how to find it now? Okay, the responses have stopped coming in, so I think I can close it. It looks rather conclusive. We have 12 hands raised and 1 hand not raised out of 13 participants. So it looks fairly positive, and of course we'll have to go to the mailing list to make sure, but it looks like we'll probably be adopting this to pair it with the UDP options draft as mentioned. Okay, Gory, what next?
I guess I should ask if anyone has any questions directed to this draft, although it's not changed a lot over the time. We saw a few discussions on the mailing list, and if you have anything you want to ask in the meeting, please do so now. After that, we'll move to the implementation presentation from Tom. So any questions? Okay, please ask questions on the list, and as indicated by Wes, all adoption calls will be confirmed on the list, so there'll be a chance to pass comments on the adoption as well when that email goes out to the list. So the final slide deck we have on UDP options is a little feedback from Tom. He has a standing invitation, along with anyone else who's interested in providing implementation feedback, to just tell us what's been going on with people who are tracking this code and trying to implement it. So over to Tom.
Can I have the next slide, please, Wes? Okay, so we at the University of Aberdeen have two implementations of UDP options, as I just said. We have a test suite written with Scapy. Scapy is a Python-based packet generation framework, and so in the Scapy implementation, we have an implementation of what is UDP user request in a BSD network stack. It sits on top of BPF, and it allows us to write UDP applications, and the UDP applications can include UDP options. This is all Python-based, so it doesn't really look like a socket API, and it's intended as a testing tool, but it is enough that you could write a UDP application, and there are some UDP applications as part of our test framework. And the second part we have is a FreeBSD kernel implementation. The kernel implementation, so the tree you see here is, it hasn't been rebased on top of FreeBSD since the FreeBSD project moved to Git last year, and so it is a little behind. This pairing of tooling is very intentional. So we have the test suite written with Scapy because Scapy is one of the tools that the FreeBSD project will use for continuous integration. And so what we have is the first step to allow code to land in FreeBSD. We have a test suite that can drive the kernel implementation, and we can verify functionality. So we can verify that a host is doing the right thing, and we verify that a host running a C-based application is doing the right thing. And so there's an extra layer in the UDP options tools where we have user space applications which are using UDP options, and we can test this different functionality. And so we have all of the pieces here to land code in the tree and keep it working with continuous integration. Can I have the next slide, please? Because I can't remember what it is. Yeah, our code was originally started in 2017 as part of a European project, which has since ended. And so the kernel implementation is not seeing, it's not getting a lot of care and attention right now. So the last update was August last year, where I got everything up to date with FreeBSD at that point. And I got the test suite to the point where I was happy that we were testing things, but we're still quite far behind what is now the set of drafts that we have. And so the code implements draft 09 with dplpmqd because we're writing this to help support the document we have. We have a simple socket API, but it is different from the API that Joe presents. And so there's work that needs to be done here. Both implementations would need to be updated to the latest draft. But probably more important for me is that if I change hats from internet engineer to a FreeBSD developer, I'm unhappy to land this code in the operating system without a real world application and without a real world user. Code that isn't getting used, even if it is a test suite, isn't really getting used, rots very quickly and things break, and this is where bugs will come in. And I'd be hesitant to put this into the kernel behind a build flag, because I sort of think that's where code goes to die. And so we have the code here, but what we're really lacking is applications. And I've been contacted in the last month about UDP options and its status by people looking to explore its use, but they've never told me what they want to do with it. And that would be a driver to get things up to date, to bring things up to date for me. The next slide, please.
So I see in the chat, Karsten wants to know if socket extensions will be documented with the protocol, and then Mike is in the mic queue.
Okay, Mike first.
Does your implementation include fragmentation and reassembly, or exclude it?
If you give you the next slide, then I can give you a list of everything we don't implement right now. So since the last major set of development, the fragmentation concept has changed a lot, and light has gone away. I was very unhappy as an implementer with how complicated the situation was, and I didn't want to implement this. As an implementer, I'm very skeptical of the utility of frag, and so I would be happier with the limited suggestion that Gori has. What I see when we talk about fragments is bugs and security critical bugs. But I think now with the changes and with the suggestion Gori has made, I'd actually be happier to incorporate this. This list here is the way where we differ now from UDP options. Oh, sorry, I'll answer Cabo. I guess it's more of a question for Joe. What will socket extensions be documented with the protocol? So it's what will actually end up in UDP options rather than what our implementation has. If code lands in FreeBSD, it will be documented in a man page. So there will be documentation for whatever we do. That would be a requirement for me to land it, which isn't in this list here because it's far away. You just ask again if that wasn't clear enough. So we're still missing these features. We're missing, I'll just read from the talk, I think it's helpful. We're missing the API that is in the draft right now. Our API is completely different because there wasn't an API in the drafts when I started, and I had to invent one. I don't have the extended options format, and reading this week, I don't see anything yet that exercises this. So it would be very difficult for me to write tests for this. I might just have missed it. I'm happy to be corrected for this. We're missing frag, ACS, MRSS, and unsafe. And we're also missing, and these are marked with a star because they're required. We're missing auth and encryption. I'm not sure auth and encryption will be something that we will implement, but they're also not on the required list. But it does mean that the unsafe code won't be touched. The spec won't be touched by an implementer that is me. It would take somebody else to come and work on this. And so I think my main motivation for talking to the working group today is we've presented before that we have an implementation, and the presence of an implementation is going to be used later in the Ietf process. But I think the working group needs to be fairly apprised of the status of the implementation compared to where the standard is right now. And so these are the pieces that are missing. And I think this needs to be considered when you say there's an implementation. You need to say that the implementation is 3 years out of date, and it is missing a lot of the features. And that will show us the parts of the spec that need the finest attention because no one has written code against them. And it will tell us the things that maybe are complicated and maybe actually want to be pushed into extensions of UDP options. I'm not saying this has to happen, but this is the things I have done. And so this is the ground I've touched. Next slide, please. And then, so I really have a question for the working group and for anyone involved. If you're interested in UDP options, if you have an application, please tell me about it. It doesn't need to be on the list. I'm happy to talk about this offline, but I really need to be convinced that there is a future for the code I have written before I put more effort in maintaining the code. Because right now I'm not seeing applications pop up, and I know that this is always a chicken and egg situation for any protocol, but we have an implementation. So applications can come through, but I am still not seeing any drive for this yet. And I would love to see drive for it because it was fun working on this, and I'd like to see the implementation continue to exist, but it's hard to justify spending more time on it without a user that will allow me to get this code committed into an operating system. Okay, that's all I have.
Other questions or comments on this from the room?
Yeah, I just wanted to reinforce what I said in the chat. I think it is important to have a standard mapping to socket options or the socket mechanisms, maybe including CMSG. So I think that really needs to be part of the development. It's certainly also good to have an abstract API if you want to do this on a random operating system that doesn't do sockets. Yeah, sockets are used enough that not having a standard socket API is probably not going to help the protocol at all.
Carson, I think that's a really good point. I think we can learn from DCCP that without an API defined, adoption will be very peculiar.
Go ahead.
In case of STTP, we at least initially did separate informational RFC describing a socket API. with all the constants and the function prototypes and whatever. And that helped to be able to write applications which are portable. But it's not in the base spec.
Thanks, Michael. I would actually be interested to know if the working group thinks that that would be the right process. I was aware reading UDP options yesterday that it is a remarkably long document if you compare it to the thing it is extending. I think UDP is 3 pages long and UDP options is 37 pages long. So it's a big overhead to add stuff to the standard here.
I guess
Sorry.
I'm the working group chair responsible for such things. So let's talk about this on the list. It's nice to think that UDP was small. I think in retrospect, UDP is actually quite a lot of words scattered across many different places. So maybe Joe's doing the right thing in writing it all down. But the question about the API and how we should define it, I think we could discuss on lists. So have a think, people. If there's energy to do this and people want it, informational documents describing APIs are within our charter for the protocols we run. So have a think, see what you want.
Just a final point. So Gori and I wrote RFC 8304, which described the services of the UDP API, and we did that secretly in TAPS. But I think a document that is light that describes UDP options could be quite a nice thing, and it could actually document the services from the API as well.
Okay, Joe gets the final word, and then we move on to SCTP. Joe?
I was going to say that I think that I'm not sure I like the idea of putting it in a separate document, only because it splits things in 2 different places that are tightly related to me. I think that the IETF made a very, very, very bad mistake saying that it was not in the business of APIs. I think it should not have been in the business of BSD APIs versus other APIs, but TCP has an API in it. It's the abstract API of open, close, et cetera, et cetera. It's the things that that became the socket. I think here too, this is all in the sort of set sock opt kind of stuff of how all that gets listed. I don't think it's all that much harder than that though. But yeah, we can talk about it further on the list.
Ahead, discuss it. There's no ban on discussing APIs. We'll figure with our AD about how best to structure that in the RFC series. But go ahead, talk about it on the list. Thank you, Joe. Michael, it's time to talk about SCTP. Over to you. Can you give us an update on the 4960 working group last call from the document editors?
Yes. So this is about the 14th revision of 4960 bis, which covers, next slide, 2 revisions from the last IETF. This is the whole history. Next slide. And you see in the dark black, well, not gray color, you see the 2 revisions which have been submitted after the last IETF. The 13th one was covering feedback we got on the list before the last the confirming working group was started, and that's basically making sure that if an endpoint is aware of a new selection of a selection of a new source address when sending packets, then it should reset its congestion control state and so on. The wording regarding the constant L with respect to ABC was a bit improved because in TCP/M there was a discussion whether to update the document or not or whatever. So basically, it's the content is introduced now, and it's allowed to use a value larger than 1. And the wording has been improved more, so it's using more consistent terms like suck chunks and that kind of stuff. And it was brought up at the last meeting that there should be a list of changes in this document with respect to RFC 4960 that has been added up to the document version 12. That was only the reference to the RFC doing the documenting the changes. So now you have also a high-level list of things which have changed between applying these differences and the current document. During the working group last call, the discussion came up how to handle packets containing init chunks with illegal parameters in it. So you have like a number of streams, you have the initiate tag. And these numbers are not allowed to be 0. So how should you behave? And the document said you should send an abort. What was not clear is that if you get a stream sequence, the number of outgoing streams is 0 or something like that, you should send an abort using the verification tag, which is the initiate tag of the init you're complaining about. And if you have an existing association, you should not change that state. Because basically you just do a matching based on IP addresses and port numbers, and you have no verification tag you check against. So you should not abort the current association or change the state. This came up as indicating that the Linux kernel implementation has a bug there. In that case, it was triggering an abort being sent with the correct verification tag, which means the peer would change the state to close. There was also a bug in the BSD stack which changed the state. This wording has been improved by explicitly stating which verification tag you need to use and that you must not change the state. So the wording in that area has been clarified by being very explicit. Next slide. And basically that's it. I submitted that document yesterday, so I'm not aware of any open issues or any pending text changes. The text changes I made were discussed on the list, and the people who reported the issues responded back that they're happy with the change. So from my view, the document is done, and I don't have anything right now I could do about it.
Thanks, Michael. And I guess that means I have the document. I will take the document as working group shepherd, and I will start the process of preparing a write-up. This document is still a work item here. It's one of our core protocols. So we are concerned that the document is both good quality and is correct. So if you do see anything further in this document, please talk to us, but we will now prepare, based on that revision of yesterday, a write-up for this to progress this to the IESG. Thanks for all the work. On to the next topic. The next topic is the topic which we've had for one of the longest times around. It's the subject of how we handle NATs and multi-homing and all these things. And we're trying to give this a little bit of a push at this meeting, this interim meeting. So I asked Michael if he would prepare this talk to talk about containers to get that discussion going a little. So go ahead, Michael.
the fact that the working group document describing NAT for SCTP, which is around for a very long time, focuses on typical NAT scenarios where you have a NAT at home, something like this. Recently, the use case of some people looked into using NATs in the context of signaling transport, where SCTP was originally developed for. And this is based, the reason for this is that they are looking at using SCTP-based applications in container environments, mostly based on Linux stuff, but I'm trying to be generic. Okay, next slide. And the impression I have is that there are tons of tools for doing this for TCP-based solutions. People have developed techniques to do that, and they do not cover multi-homing. Because TCP doesn't support multi-homing. I mean, I'm not talking about MPTCP, but plain TCP. So they are trying to adopt the solutions they use for TCP to the use case for SCTP. And sometimes this brings up problems like having to modify stacks to behave in a non-compliant way, or to add specific features, or to get complex other solutions into the game. And I wanted to make sure that one possible solution, at least from what I see, people are aware of, and I would like to get some feedback if this is something being worth specified. So I'm not focusing on any particular container technique, but I think it works for it should be able to get this somehow working in different container technologies. Next slide. So what people are doing is they want to provide reliable service. So they have to deal with network failures and host and endpoint failures. One way to deal with network failures is to use SCTP with multi-homing. And one way of handling endpoint failures is to use a cluster. I call it generically a cluster. So you have multiple cluster elements shown here, all being able to provide the same service. And what you don't want to do is, if someone wants to use this cluster, a peer should know all the cluster elements. So normally what you have is, let's say, 2 IP addresses, for example, which you can connect to, and then you will talk to one of the cluster elements. So you have a distributor function somewhere, and this distributor function basically does, when it gets an incoming connection request, it will decide which cluster element will handle the connection, and then make sure that the packets go there. Next slide. One way to do this is for these distributors using NAT. In this case, it would be an SCTP specific NAT where we have 2 presentations for. You have to find a way to distribute the incoming connections, and you have to do it in a consistent way. So if the packets are coming via the above or the upper or the lower distribution function, they have to end up at the same cluster element. So if you are looking into the information you have available there, that's not much, because you can't use the IP address, because the source IP address is not constant over the multiple path. So that's not trivial. You have to have support in the endpoints, in the NATs, and you have, well, not single point of failures, but if one of the nets dies or loses its state, then it affects all cluster elements. So that's something people try to optimize and look into. Next slide. Another thing I have seen is don't use two distributors, use a single one. Then it can more easily deal with the internal structure. And if you go to the next slide, then you see how this is sometimes realized. They terminate at the distribution function. They terminate the transport connection and set up internally another transport connection and relay the user messages. That's also a possibility. It does not require code changes. You can just build it. However, you have a single point of failure. So if your proxy dies, then all the connections to the cluster elements go away, and you have a bottleneck, a performance bottleneck. So next slide. Conceptually, what you could do is you could have the distributor functions, but both of the both solutions I described up to now, they hide the internal structure. So the peer cannot see the internal addressing of the cluster and that kind of stuff. In this situation, you would be able to observe this. However, what is important is that if some peer wants to talk to the cluster, initially it doesn't have to know the internal structure. It just has to know the two IP addresses, let's say, from the distributors. And the idea here is, next slide, that the client sends a connection request, which is an init chunk, and puts in a new parameter. So a code change is required here. And this parameter says, I'm supporting the extension I'm talking about here, which basically is, I'm sending this init to one of the distributors, but the distributors are allowed to forward this. So if one of the distributors gets the init, it takes the init, it decides based on whatever algorithm it uses, which cluster element will serve this connection request, and then forward this init chunk to that cluster element, and puts in its own address in the init chunk, and then basically the cluster element sends back the init egg. This init egg for the client comes from an unknown address, so that's why this init forwarding parameter included holds the original address the init was sent to. And after that handshake, everything runs as normal. You don't need any special things. You can set it up multi-homed. Implementing this is very simple, and you can put all kinds of logic at the distribution function, including any algorithms, how to do the load sharing, how to supervise your cluster that you don't forward it to some dead node, whatever. Next slide. So the pros and the cons. So the pros is the distributor only needs to handle connection requests, so it's very lightweight. And if it dies, you can have a different one coming up. You don't need to have long-lasting state. That should be very easy. That should be a very simple thing to implement. Also, at the endpoints, it's very simple to implement. You just have to, if you don't find the association based on the address, you just look up this parameter, and you can find the association. For changing IP addresses during the lifetime of the association, we have this ROC, which does ASConf, which is changing the IP address, adding one, deleting one, and we already have such lookups parameters there. The only point for this extension is that this ASConf parameters can't be included in the init or init-ag. So this is just a very lightweight thing to do here. The negative, I'm not sure if it's, well, one thing is negative, because every cluster node needs an IP address, which can be IP addresses, which can be used to communicate with a peer. So if it's IPv4 and if you're on if you are using public IP addresses, then you have to have public IP addresses there. I think that shouldn't be a problem if you go to IPv6, since you have a lot more IP addresses there. And the other one, which might or might not be something you consider negative, is that the IP addresses of the cluster nodes are exposed to the client. So after the client contacted the distributors and the association has been set up, the client knows these IP addresses. But if you're willing to take these costs, it's a very simple thing to add and should allow very easily to set up clusters in containers using multi-homing. With code change, it's much simpler than, for example, implementing nets on the middle box side and on the endpoint side. I'm bringing this up here because it's recently I was contacted multiple times about this stuff, and the question is if this seems something like we should write up and draft, implement this, and do this within the working group, or if people think this is not applicable for containers and so on. Any feedback welcome. I think you're still muted, Corey.
I think Gori is actually still muted.
Gori, you are still muted.
Yep. Go ahead, Magnus. You're one in the queue. Anyone else, please join the queue if you want to comment on Michael's presentation, and then we'll move into the next presentation where we can have similar discussion as well. But go ahead, Magnus.
Okay, thank you. This is Magnus. I mean, I think this is interesting, and I think there's some forward-going benefits, etc. But I just want to note that we do have some environments today where we basically have NATs in place, and there is single address per network, so to say. I would say Kubernetes here, which probably is how it's. Is one of the things that makes it a bit harder. So you still have the NAT function there between your containers and the outside.
So as far as I know, I'm not an expert on this, but as far as I know, you can have in the container, you can map an external address from the host into a container.
Yeah, I believe you're correct there, but it's the question of when you can do it, etc., and what your addressing structure is, etc. So, but yeah.
So basically, the question is whether you are willing to assign an external address to your container or not. That's what I wrote on this cons, because that's what I'm not sure about. If you're not willing to do that, then you have a problem. I mean, then this doesn't work out.
Yeah. No, so I think from my perspective, I think we need to some degrees there's two questions here. Saying it's one thing about how do you handle load balancing for multiple instances. That's one aspect. There's another thing which is the NAT aspect, saying okay, you will likely have NATs even if you are multi-homed in some cases.
My point is you don't need NAT here. So if you want to run an application in a container environment, then you need this load distribution thing. But if you're willing to assign to your container public addresses, you don't need NAT here, and that's the point.
Yeah.
Then your life can be simpler.
Yeah, and I don't think the world is simple that you would always be able to get rid of the NAT, unfortunately. But yeah,
Well, Michael, I think that was a useful talk to try and get this discussion going. So thanks. And I think we can take more questions on this if there is time. First of all, let's take Martin, and then we'll go into the next presentation. Martin, you got a question?
Thank you for this presentation. I want to zoom out a little bit, and I'm just seeing, you know, when I took over this, when I became responsible AD for this group, there was, you know, 4960 BIS and the SCTP NAT document. Now there's this, and I'm looking in the individual drafts under this group, and there's a lot of ferment on SCTP. And we don't have time to discuss it now, but I would be interested to know. I'd be interested if there's broader interest in all of this work, and if so, if it's time to consider an SCTP BIS sort of working group. I know that there's some things that are almost done, but a lot of things that are kind of midway through or just starting out. And you know, if there's a lot of documents going on, then it would be great to take some of the load off of TSVWG. Thanks.
Which brings us nicely to the next talk, which is another alternative proposal on how to do NAT support. And this is introduced here to try and get people thinking about the topic. So I would suggest listen to what Claudio's got to say, and then let's ask questions afterwards. So go ahead, Claudio.
Yes, please. Okay, this is in the
need to be a little bit louder if you can.
Okay, can you hear me? Can you hear me? Does it work?
Yeah, a little quiet, but still good.
Okay. Say that this is actually an approach to having SCTP behind NAT, and it has been triggered by the same problem, that is having that in an environment where you have containers. Please, next slide. So in the next slide, there are the use case, and then we see that the big case that is new on the scene is this distributed endpoint, and this is quite a normal case in cloud deployment. And cloud means also that you have those containers. Please, next slide. This is what exists today. So this is how Kubernetes provides network access. The slide has been taken from one of the CNI, that means Container Network Interface. That is Kube Router, an open source CNI that provides this level of abstraction. There are quite many, and Kube Router is not one of the most well known, but it has a very good explanation on the web to be stolen. Here you can see that you have an object called pod. Pod is a sort of lightweight virtualized machine where you can run your service, for instance, an SCTP host. And each of those pods has a local IP address, and it has only one IP interface, only /dev/eth0. Then all the communication that is internal with other pods within the same physical machine or over other machines that are building up the same cluster happens via a very complex mechanism that sets the NAT rules. All this is kept working with a number of replicas of another object called Kubernetes master. And Kubernetes masters is listening to all the process ID of all the objects, and then when a certain pod, for instance, dies, or a service in a pod dies, then it reinstantiates the pod, possibly with the same IP address or maybe with another one, but it also fixes all the NAT tables on the fly. So it is a very robust system for deployment over the cloud. It allows scalability, and it provides a level of redundancy, so that in case of HTTP server, for instance, if you have replicas of the same HTTP server, then the query will be directed towards a live session of the HTTP server in another pod, and you will hardly notice it. If you think to SCTP in the pod, this doesn't work very well for the well-known problem of SCTP working with the NAT. And then we have the problem of multi-homing that Michael is approaching in a different way. But this is a challenge, and since more and more network node, especially in the telecom, are going to be deployed over Kubernetes, then the problem of having a well-working SCTP service behind a NAT, where the number of SCTP hosts share the same endpoint, is I think quite new on the scene and needs to be handled. That this is inspiration, one of the inspiration of my work, but my work is a general approach for having SCTP behind NAT, and it's mostly inspired from the work that is ongoing at Ietf for a long time, and where other people have contributed, including Mikael, who helped me a lot in writing this draft. Next slide, please. So the approach of this proposal is that rather we want to have a NAT that doesn't really inspect packets and does what is the bare minimum activity. So it only parses the common header of SCTP, and then it only takes care of discriminating SCTP packet containing init chunk or not. When having init chunk, it can check for collision. Otherwise, it behaves in a different way if packets are incoming or outgoing. The way for discriminating packet with init chunk is that if in the common header the tag is 0, then the packet is containing an init chunk. So it doesn't really need to parse the SCTP payload. The collision, there is a minimal communication between a NAT and SCTP host, and it is the same as in draft TSWG. So when a collision is detected at a NAT will send an abort with mbit set, and then the host will know that it is not possible to proceed with this init towards the peer. It's not reaching the peer. The way it reacts is that if this is the first init for setting up an association, then it will the user, the SCTP user, will be communicated, and then it will eventually decide to change source SCTP endpoint. That is changing the port number for creating the association, and this is repeated until it gives up or it finds a port number that works up to the peer. The multi-homing is implemented as a single homing that is extended with ASConf, and this is also the same as in the draft that is ongoing. And then there was my idea to use an extra option that tells the peer that the init chunk is used for creating the path for multi-homed association, but thanks to Mikael, then I understood that this is not needed. So this part of my proposal can be removed, and it will be removed. Can you please proceed? Next slide. Yeah. Okay. In the NAT implementation, this is quite simple. So it only keeps the 4 tuples for the association that's called association state, but actually the state is only the association exists or it doesn't exist. The NAT uses a timer supervision that checks if there are still packets ongoing on the association or not, and when the supervision expires, then the table entry is removed. When receiving an edit check, as I said before, the NAT can answer abort. Otherwise, it creates a new entry in the table and forwards the packet. And when receiving an outgoing SCTV packet that is not in it, and the table exists, the entry exists, it's forwarded. Otherwise, a new entry is created in the table, and then the packet is forwarded. But when the packet is incoming and the association, the 4 tuple, does not exist, the packet is going to be silently discarded, meaning that the only packet that can set up all the path from source to destination is only init. Please, next slide. This is the algorithm for handling init in NAT. So when init comes, it checks for the collision. If there is collision, it will send back an abort with mbit set. Otherwise, creates a new NAT table entry and forwards the packet to the next hop. Please, next one. Other packets are handled in this way. So if the packet is outgoing and then it is in the NAT table, it's forwarded. If it's not, then a new table entry is created and it is forwarded as well. If it's not, if it's incoming packet, if it's in the NAT table, it's forwarded. If it's not, it's silently discarded. Next slide, please. I think it's almost last. For multi-homing, the approach, as I said, is the same as in the draft. We need to set all the NAT function so that before sending the isconf, we need to be sure that we have the path available. So an init is going to be sent to the remote feeder on the new path. If we receive an init hack, then we follow the procedure for isconf according to RFC 5061. Otherwise, this path cannot be used for multi-homing and it's being kept off the association. Here I said that repeat event is not needed. Next slide, please. When we have a distributed endpoint, it happens that we have multiple hosts that can be addressed by init, as the NAT cannot decide by itself. Also because there can be different rules for distributing the load. So I say that this functionality for handling distributed endpoint needs a load balancing function, but I'm not describing the load balancing function here. It's only needed. The strategy can be different. It can be based on source IP address. It can be based on the load that is counting the load on different hosts. So it's simply not the right place here to say that. In the example that I have drawn in the proposal, there is the NAT is implicitly described. I think that if we proceed with the draft, then this needs to be clarified. And then please, next slide. That I think is the last. This is a minimal approach to solve the problems of NAT and SCTP. The idea is that the simpler the NAT, the easier is that this solution is going to be adopted. We don't need to have VTAG handling. We don't need to make VTAG-based routing here at NAT, but collision is collision and is not going to be solved by the network. It's the user that needs to solve the collision by itself. I think that since we have most of the concept in common with the draft NAT soup, we can see this as a simplified version of that, or even maybe a first step for going into the same direction. Last but not least, Mikkel and Magnus both have helped me a lot for the work. And then I wish also to thank all the authors of the existing NAT SAP, because it's a very well done, and it covers also, you learn a lot, even only by reading that part. I have only 36 seconds. Please, if you have questions.
Okay, I don't see people in the queue, but I still very much appreciate the presentation. Thanks for going through this and for bringing this subject to a bit more attention and focus on your use case. I'd like to come back to this and talk about this more in the working group, but I would love to spend the last 10 minutes of our meeting today looking back at our NAT sub draft and seeing whether we can actually progress that now. Now we've teased out this difference. Is that an item that we can progress as a working group, or should we be taking that back to the design stage? So that, I think I'll hand over to Michael to try and talk a little, and I really love to be able to ask that question, if not now, to ask it very shortly on the list. So go ahead, Michael, with slides if you like, or just talking.
Just if Wes could use the slides, run the slides.
I don't have another deck. You want the previous deck?
Well, there's one with NAT at the end.
I don't have those myself right now.
Okay, so I can try to say what I want to say, basically without slides. So the original document goes back, focuses on consumer nets and the observation that normal consumer nets resolve local port number collisions by using NAT, and basically the document describes a way of doing this without changing the port numbers, because you can't do that, and we agree on that. Basically, it uses the verification tag to get a connection identifier. And if you look at the state information the NAT holds, then the solution proposed by Claudio and our solution both have the internal port and internal address. Our solution has the verification tags, obviously. Claudio's doesn't have that. And Claudio's suggestion has the remote port and the remote address. Our solution does not have the remote address anymore. Originally it had, but there was a paper showing that if you use the verification tags, then you don't actually need the address. It only complicates things, so that was taken out. And obviously, we require special handling at the endpoints of the association, so the restart procedure has to be disabled, and we carry this flag there too. So basically, going back to an older version of this document, where we also had the remote address, then the data is actually, and the handling is actually, what Claudio presents is actually the special case of the endpoints don't support any special NAT handling. So one could with getting back the remote address, one could consider that a special case of this, except the multi-homing, where Claudio's suggestion just the net doesn't parse the chunks; it just looks at the vtex. So if one could say, okay, we are parsing the packets in the NAT where we detect ASConfs and add also state. So it's for incoming packets where Claudio's solution only adds states for init chunks, and it would be changed to if it's an init chunk or if it's an ASConf chunk, which could be the second, which could be reduced to be only the second chunk, so the parsing could be limited. Then one could consider that a special case and even move the verification thing to an appendix or whatever, and say that's a way you can do if you care about local port number things, but details have to be provided in a different document. That is kind of the relation, from my view, of the documents as they are right now. Does that help, Gori? And is that view correct from Claudio's perspective?
Yeah, I think I'm most interested in Claudio or Magnus if they have a comment on this, because they were the people who raised the issue in the first place. And what I'm really asking is it a small thing to make this NAT sub work item be a document that's useful in the context, even if another document is required afterwards? I'd love people to talk to this and help me understand.
Can you repeat the beginning of the sentence?
Yeah. What I'm asking is it useful to publish the NAT sub document with the changes maybe that Michael's outlined now, and complete that publication, publish that as an RFC? Does that help them, or is this kind of so contradictory that we shouldn't be proceeding with it? And we should take that back to the work item and we should start looking afresh at this topic. It's a difficult question at the end when we're doing the working group last call, but we need to publish a useful document. So I'm saying, is there utility or usefulness in a small change to the NAT sub document and going ahead? That's what I'm asking. Is that a good thing to do? And primarily to Claudia and Magnus, but anyone else who has read these documents?
I don't think that the documents they are contradicting. It's a slightly different approach, but I mean, there is a lot in common.
I mean, as I said, with taking away some of the details, Claudio's suggestion is just a special case of the working group document, and it's the special case where the endpoints don't support this extension. And I mean, and I think it's a good thing to focus on the use cases where SCTP was originally designed for, which is signaling. And so I'm not objecting against moving things around and getting to the simplified version. If
I think this is useful, and I think it's something we can talk more about. My chair opinion here is that I will talk to my area director on this topic. And one possible outcome is that we simply take this document back to the working group and perform some edits to make it more useful in that signaling application. And if we can do that and do that successfully, then I think that's a worthwhile activity to embark upon. So I'm going to talk to my area director and seek advice about the best way to address this use case. And with that, we are almost out of time. If anyone wishes to rush to the mic and comment on what we've just said, please do, or put it in the chat or email one of the working group chairs.
I will jump
Magnus?
in. Yes. So, I mean, about this, I think there's an interesting relation here is that most of those small home office NATs or deployments, if they have SSDP, I wouldn't expect them to have a lot of SSDP associations. And therefore, the whole VTAG mechanism is not as needed in that use cases. In some sense, it's the larger, very much clustered deployments that might require the VTAG, but it could actually run out of ports. But there you would also, for the multi-homing, need to have more complicated mechanisms for synchronization. So I think it's like, if we can enable this here, you can probably simplify for the home use, the smaller NATs, still make things work and have a road to doing more complicated things also. So
Okay. So Magnus, are you going to stick with this topic and help provide inputs?
yeah, I mean, working with Claudio, trying to help him out, etc. So it's I expect it to be, but yeah, I would expect us to. I hope that we can actually try to see how we can make this as simple as possible and not blow up the word more. I'm sorry about the whole thing, but it was unfortunately very late realization here. Yeah.
Okay, we will try and do the right thing. As regards this meeting, we are about to end it. We will take notes. Thank you for our note takers for recording information. We will produce these notes and send them to the working group. Wes reminded us that he's going to issue an email on the L4S working group last call shortly. And we will look forward to probably organizing another interim meeting before the next IETF, if there is a need for that. So thanks ever so much for coming, and enjoy the rest of your day wherever you are.